Good morning, dear students. Today we are going to start our section with the topic oxidation of triglycerides. This oxidation of triglycerides is otherwise called lipolysis. And where this lipolysis begin? It begins in adipose tissue. It begins in the adipose tissue. And what triggers, what stimulates that lipolysis process? It is triggered by low glucose level in blood. That means whenever in our blood, when the glucose level is reduced or lowered, that time this lipolysis is initiating, is beginning. Okay, so first we need to understand about the important enzymes in enzymes that functioning in this lipolysis pathway. They are three. First one is ATGL. ATGL means adipose triglyceride lipase. What it is doing here is it converts, it hydrolyzes triacyl glycerol to diacyl glycerol. What it is doing here, it hydrolyzes triacyl glycerol to diacyl glycerol. Then another enzyme is here, its name is HSL. HSL means hormone sensitive lipase. What it is doing is that it hydrolyzes diacyl glycerol to monoacyl glycerol. Then a third enzyme, important enzyme is there, MGL. And it is monoacyl glycerol lipase. And what it is doing is that it hydrolyzes monoacyl glycerol to glycerol. So these are the three main enzymes that present in lipolytic pathway. And along with that, one regulatory protein also present. Its name is perilipin 1A. So that is a regulatory protein. It is regulating the lipolytic pathway. So we can go and see what is the process, what are the steps in that pathway. So this is an adipose cell in the adipose tissue. And whenever the glucose level in the blood lowered, at that time epinephrine is produced from the adrenal gland, and that epinephrine hormone goes and bind with a receptor. What is the name of this receptor? It is a G protein coupled receptor. We can see the G protein here. And on binding that hormone with this receptor undergoes a conformational change. And because of that conformational change, the attached G protein that is having 3 subunit bearing a GDP, it undergoes a change by replacing this GDP with a GTP. And by that way, G protein also undergoes a conformational change, and that alpha subunit along with the GTP detaches from the remaining subunit and moves to an effector protein. And the name of that effector protein is adenyl cyclase. It moves to that effector protein, and as it binds that effector protein, it converts ATP to cyclic AMP, cyclic adenosyl monophosphate. And what CAMP is doing next? This CAMP then activate an inactive protein kinase A to an active protein kinase A. We know the innate nature of kinases. It can activate some other substrate by adding a phosphate group. Okay, that we know here. So next we can go and have a glance about the lipid droplet that present inside this adipose cell. So this is a lipid droplet. So that need to catalyze, that is undergoing oxidation. On the surface of this lipid droplet present that regulatory protein, its name is perilipin, I already told you. And attached to this perilipin present another protein CG158. And also on its surface present among our three enzymes, the first one, that is adipose triglyceride lipase, it is present. And also this one, it is monoacyl glycerol lipase. And one more enzyme, I already told you, three enzymes are important enzymes are there, and two are present on the surface of this lipid droplet, and the other one, that is HSL, it is present in the cytoplasm of the adipose cell. It is hormone sensitive lipase. It is in an inactive stage. First, for bringing about that lipolytic pathway, first we need to activate this HSL. And who is activating this HSL? This activated protein kinase A. How to activate HSL? By adding a phosphate group. So it add a phosphate group and activate this HSL. After got activate, this HSL moves to the surface of the lipid droplet. Okay, so along with the activating this HSL, this active pKa is adding phosphate group to this perilipin 2. So that phosphate group is adding to perilipin, it also got activate and it moves to the surface of HSL. Okay, then this pK is doing one more activation, that is by adding phosphate group to CG158. And this after got activate by this phosphorylation, the CG158 also is moving and it associate with the ATGL and activate this one, this enzyme. And on activation, this ATGL hydrolyze triacyl glycerol to diacyl glycerol. And then this diacyl glycerol is then hydrolyzed to monoacyl glycerol by this HSL enzyme. And this monoacyl glycerol is again undergoes hydrolysis under the influence of NGL enzyme to form glycerol. And also we need to understand this, understand that all these DAG, MAG and glycerol, all these can further undergoes hydrolysis to form free fatty acids. They all can undergo hydrolysis, further hydrolysis to form free fatty acid. So this is the lipolytic pathway. I hope that is very clear to you. With this, we can finish today's section. Thank you. I'm an icon, man. My girl about a 10. I should fuck her in a Benz.